Alright class, we're going to continue our talk about domain restrictions and composite functions. Again, remember, when you have an even root, you cannot have negatives under that root. So, since this is an even root, and we can't have negatives under there. Now, you should simplify this to make sure, because sometimes this would be like x to the sixth, and because there's a sixth power here, this number will never be negative because the sixth power will always make it positive. However, since this is an odd one, you can still end up with a negative under there, which we can't have. So our domain for this one is that x just cannot, it has to be bigger than or equal to 0. Now in this case it's allowed to be 0 because it's not on the bottom of a fraction. This problem, it's simplified. We look at it. We can't have a 0 in the denominator, so no 0 in the denominator. And what number will make that 0? Hopefully you guys see that it's just 6. So the domain restriction is that x cannot be 6. It could be anything else. Here, before you can say the domain restriction, you should factor to see what it looks like. And again, this is another one where the denominator cannot be 0. 0 won't work, and 3 won't work. So x cannot be 0 or 3. This one's a little trickier. We have a denominator and a radical. So right away, x has to be positive numbers. But we have to check to make sure that all the positive numbers work. This whole chunk cannot be 0. So the thing we have to do is solve for what makes this 0. So the square root of what is equal to 3? Hopefully if you square both sides you get that x equals 9. So that means that if you stick a 9 in here, you get 4 times 3 is 12 minus 12, which is 0. We cannot have that. So the domain restriction is, first of all, that x can be greater than or equal to 0. So it's basically saying it could be 0, because in this case x can be 0, because then you just get negative 12 on the bottom and that's okay. However, the number that makes it 0 though on the bottom is a positive 9. So we would say that x is greater than or equal to 0. However, out of those numbers it can't be 9. Okay. So when you're doing composite functions, you have to first see the domains of the individual pieces. This is the same thing as saying 5 over this x to the 1/2, which is the square root of x. Now we're not rationalizing right now, we're just doing composite functions, so we can leave it like that for now. The domain restriction for this is that x has to be greater than 0. And here's why. You're under a radical, so it has to be greater than or equal to 0. However, 0 doesn't work because you're on the bottom of a fraction by itself. And if you put a 0 in, you'll get a 0 on the bottom. For this one, the domain is all real numbers. So remember, when you're doing composites, you look at the domain of what you put in. So in this case, we're putting g of x in, which is the all real numbers domain, which is good. And then we look at our final answer. So I'm sticking g into f. So here's f. So f of g of x is equal to 5 over the square root, and I'm sticking in g of x, which is x squared, and we just get 5 over x. And if you look, so again, the thing we input had no problems with domain, and then our final answer is that our domain cannot be 0, because then we get a 0 on the bottom. So here's the answer, here's the domain. We can do the same thing here. Domain restriction is that x has to be greater than 0. And now we're going to stick that into g of x. So we get 5 over the square root of x squared. Okay? Now what happens is we get 25 over x. Normally, you would look at this and say, oh, it just can't be 0. However, you have to look at the beginning restriction as well. In order for this problem to work, f of x could not be negative numbers or 0. So, we would say our domain is that x is greater than 0. It has to be greater than 0. Okay. Now these say use a graphing calculator to find or check the following. I'll show you that in class, but right now I want to just show you what you have to do. First thing this is saying is find g of 3. So g of 3 is equal to 2 times 3 plus 1. I don't need a calculator for this. 6 plus 1 is 7. So that's the answer. So this problem now turns into f of 7. That turned into a 7. So now I can solve this by plugging a 7 in to the f function, and then you get the answer is 143. So the final answer to the problem is 143. And you can do that a bunch of times. So if I do f of 3 first, f of 3, you just plug a 3 into the f function and solve, and you get 23 for f of 3. So that's that. So now we want to know what g of 23 is. That's going to be a big number. Well, actually not too bad. You get 47. So the final answer for B is 47. We already know what f of 3 is once, right? So f of 3. We found this on the last one. F of 3 is 23. So now I want to know what f of 23 is. And this is going to be a big one. This is the big one. So when you plug that into your calculator, you get 1583 as the final answer. F of g of x. That means I'm sticking g of x into f of x. So I get 3 parentheses, g of x is 2x plus 1 squared minus 4. Okay? Now if I ask you to simplify this, I would have you then FOIL this piece, right? You get 2x plus 1 times 2x plus 1. You can do that first. Minus 4. You get 3 times, this becomes 4x squared plus 4x plus 1 minus 4. And when you simplify that by distributing the 3 and subtracting the 4, you get 12x squared plus 12x minus 1. Okay. Alright, last problem, and this was actually on the other video that I said don't watch, but now it's on this note sheet. Computer Catalog offers computers at a savings of 15% off the retail price, and then after that, at the end of the month, it offers an additional 10% off its own price. It says use a composition of functions to find the total percent discount. Well, first we're going to say that the sales price with respect to the cost is 15% off means you're paying 85% of the cost. So that is that one. Then we also know that the final cost, the final price, with respect to the sales price, it's 10% off of that. So 0.9 or 90% of the sale cost, which is this one here. So if we do a composition of functions, we want f of s of c, we get 0.9 times s turns into 0.85 c, which means that the total final cost with all the discounts is going to be 76.5% less than its original, which means that you get 23.5% off. Okay, so the total discount, the total percent, so this is the equation, so the total discount is 23.5%. What would the final price? Well, you can just plug this in. We could actually just call this now f of c, because we composed them already. F of s, s of c. And you just plug the number in. And you get that the final price of the computer would be $687.74. And that is it. So that's how you can use composite functions to do like a multiple percent discount. Or you can do them separately, you know, like you normally did. So, alright, that is part 2 of domain restrictions.